Okay, so we are dealing with production planning and controlling chapter. In that chapter, in the last lecture, we have discussed the production procedure and the line balancing. Okay, hope everyone understand that two concepts. Also, we have discussed the loading part. Okay, and the Gantt chart and visualize loading. That two methods we have discussed in the last lecture. So today we are going to understand what is meant by sequencing and how to solve, how to deal with the problems related to the sequencing. Okay, so we know that the sequencing means uh, the operations which will happen on a particular job that should be sequenced. Okay, so according to the procedure means if you want to perform any task on a particular job or a particular object on a CNC or a VMC or lathe machine. Okay, so in that case you have to perform the operations on a sequencing manner. Let us consider, first of all, you are doing the operation of installing the job. Okay, then secondly you are doing the operation of facing, then turning, then drilling. Okay, then knurling. So these operations should be performed in a sequential manner so that the time required and the material required or the processes will get optimum. Okay, time, processes and the material, these things will get optimum. Optimum means the required things are performed as it is. Okay, no extra penalty will happen in case of a time, in case of a cost, in case of operations, or no any operation need to perform a twice. Okay, so that things we need to take care, and these operations are sequenced in a such a manner that their total cycle time will get reduced. Okay, so this is one concept of a sequencing on a particular job. Okay, and in this manner we have discussed the line balancing also. So in that case we have discussed one sequence of operation, that is drilling, boring, then milling machine and then assembly line. So uh, to reduce the time which will required to perform the all the task on a one machine. Okay, to perform all the task on the one machine, we have to segregate the operations on a different machines. Okay, on a different machine, like a line balancing. If you want to perform the assembling of a particular component, and if you assign the complete assembly for one workstation only, in that case what will happen, the job will not be performed that much with that much accuracy, and some parts, there will be chances that some parts are missing out from the assembly. Okay, and you will not get the desired quality for the product. Okay, so this is the problem which will arise if you perform all the task on a one machine only or a one workstation only. So for that reason we have to segregate the task, we have to segregate the operations. Okay, and accordingly we have to design the workstations. Okay, workstations like a machines, workstation like the assembly workstations, and the particular task, okay, or a particular operation we need to assign for the particular workstation. And in this manner we have to segregate the task. Okay, once the tasks are segregated, okay, we reached up to the task segregation. Once the tasks are segregated, then we know that some of the components, if you consider that the company producing 10 number of a variety of components. Okay, and for at least 7 to 8 components one process is common. Okay, let us consider at least for 7 to 8 components one process is common. In that case the 7 or 8 jobs will come to one workstation only. Okay, 7 to 8 jobs will come to one workstation only. Now the problem is arises for that worker, that which job I need to give the first priority, which job I need to give the second priority, which job I need to give the third priority. So this is the problem. Now here the worker or the supervisor, which one is expert in a sequencing or which one knows the priority sequencing, that person will will provide the sequencing of a job or the batch of a job which that particular worker going to perform. Okay, so let us consider there are 7 jobs. Okay, and the priority need to decide on that 7 jobs. Okay, so worker is performing on one job. Okay, or he that particular worker is performing the task on one particular batch of a jobs. Okay, here I'm saying the job, that is nothing but a batch of a job. Let us consider the 100 components are there in one batch. Okay, and that 100 components need to process on a machine, and the second 2-3 batches are pending, variety of batches are pending. Okay, now that first whatever the task is in hand with the worker, that is finished, and need to take the second batch or second variety of a batch for the processing purpose. Okay, so at that time the the question in the mind of a worker, that which job should be assigned next to the processing job. Okay, next to the current job. Okay, so that question will be answered by this priority sequencing methodology. Okay, by this priority sequencing methodology. So here when job compete or participate for work centers capacity, which job should be done next, priority sequencing rules are applied to all jobs waiting in the sequence. Then when the work centers become open for the job, the one with the highest priority is assigned. Okay, so priority sequencing is a systematic procedure for assigning priorities to waiting jobs, thereby determining the sequence in which the job will be performed. Okay, getting everyone what is meant by priority sequencing? So सिंपल लैंग्वेज में आपको बोला जाए तो समझ लीजिएगा, एक वर्क स्टेशन है और उस वर्क स्टेशन पर एक वर्कर है और वो एक बैच पर, ओके, कंसीडर वो बैच 100 नंबर ऑफ प्रोडक्ट से बन गई है, उस बैच पर वो काम कर रहा है. ओके, एक ड्रिलिंग ऑपरेशन है और वेटिंग में, वर्क इन प्रोग्रेस में 2 और जॉब आकर उसके पास रखे हैं. ओके, सो एक वो 100 की बैच कंप्लीट होने के बाद कौन सा नेक्स्ट जॉब उस मशीन पर लेना है, वेटिंग में जो 2 है उसमें से कौन सा जॉब नेक्स्ट लेना है, इसका डिसीजन लेना पड़ेगा. ओके, इसका डिसीजन लेना पड़ेगा. सो वो डिसीजन यानी कि प्रायोरिटी सीक्वेंसिंग, वो डिसीजन लेना यानी कि प्रायोरिटी सीक्वेंसिंग. नाउ दिस इज द साइंटिफिक टेक्निक. ओके, we or a worker or the supervisor cannot assign random job for the processing. Okay, if you are doing that, then it will be hamper on the production plan. Okay, so this is a scientific technique in which the jobs are assigned to the work centers, or the batches of jobs are assigned to work centers or to the workers. Okay, so that is nothing but the priority sequencing. Here we are giving the priorities to perform the task on a jobs. Okay, to perform a task on a jobs. Now what will be the choosing criteria for the sequencing? So what one should think about while selecting the sequencing of a number of for a number of jobs? First is nothing but a setup cost. Okay, setup cost means what? Some products require jigs and fixtures. Okay, most of the products are required jigs and fixture. Some extra setup is required, like hydraulic presses or hydraulic holding things are there. So such a setup cost need to consider. Then time required to do the setup. Okay, if you want to change the job, okay, which is performing on the machine. So in that case, you have to change the programming, you have to change the offset if you are considering the CNC VMC machine. Then if you are considering the normal machine, so in that case you have to change the settings of a machine. So that time required, that time will be converted into a cost. Okay, so setup time will be converted into a setup cost. Okay, so how much time is required? Okay, then after providing the setup, then how much inventory is there, or how much number of a product are in work in progress at that particular location. So that is nothing but WIP, work in progress. We called it as a semi finished products. Okay, so that will also not called as a raw material and also not called as a finished goods. So some processes are performed and some are remaining. So such a inventory or such a number of products will be considered as the work in progress inventory. Okay, so we need to consider how much components for a particular variety is in work in progress. Okay, so in progress or in process inventory. Then third thing is nothing but idle time. Okay, so how much idle time? Let us consider that one process is completed for one workstation, but job is not received from another workstation or previous workstation to that workstation. So that much time will be considered as a idle time for a machine and the worker which is working on that, or the employee which is working on that particular workstation. Then if we have considered the optimum number of a batch, okay, let us consider the 100 components, how much average time is required to complete that task, or to complete that operation on the machine. So that will be nothing but a average time to complete the jobs. Then average number of jobs waiting in the queue, number of a quantity or number or a quantity, then average time the jobs are late. Okay, so this is also important. Late means what? Here I need to finish the components, let us consider up to 12 noon, but I received a component at 11:30. That should be received at 11 a.m. But I received a particular variety of a component at 11:30. So the components are late by 30 minutes. Okay, the components are late for 30 minutes. And what is my delivery date? Okay, so, or delivery time. Let us consider that to process, I required 1 hour and I need to deliver that component at a 2 p.m. Okay, so how much time is there to deliver that component, and how much time required to process that component at a particular workstation? So that need to consider and need to determine average time the jobs are late. Okay, so by considering this choosing criteria, one can prepare the rules which will helpful for the priority sequencing. Okay, so which are the rules? So we are going to consider the priority sequencing rule. So out of these rules, one can consider any of the rule for providing the priority sequencing. Okay, so first rule is first come first serve, FCFS. It is also called as a FCFS. So we know that first come first serve rule, which component comes first to that particular workstation, okay, which is in a waiting position or waiting job, the priority, first priority will be provided to that job. Okay, so that will be considered as a first come first serve. Okay, gives top priority to the waiting job that arrives earliest in the production system. Okay, then the second rule is that earliest due date. Okay, in a short form it is called as a EDD. Okay, so in this rule the top priority is giving whose due date is earliest. Okay, let us consider 10 jobs are there, and out of 10 job I need to uh, uh, deliver one job within 2 days. I need to deliver one of the job within 3 days. I need to deliver one of the job within 1 month. So the due date for first job is 2 days. 2 days, okay, and within 2 days I need to deliver that particular product to the customer. So the highest priority in this case will be provided to the job which is having earliest due date. Okay, earliest due date. Then in some cases you can provide the highest priority, the job which are having shortest processing time. Okay, shortest processing time, that is nothing but SPT, gives the top priority to the waiting job whose operation time at a work center is the shortest. Okay, so we have some we are having some people are having the thinking level that uh, uh, if you complete this particular task, then the load or the number of tasks will get reduced and the maximum time will get saved, and which will be utilized for the longer time period jobs. Okay, so in if the management thinking level in a such a manner that then this type of a priority sequencing also implemented, which type of shortest processing time. So in this processing time, what we are doing, we are giving the top priority to such a products which is having the shortest processing time out of all the products or out of all the varieties. Then least slack. So once again, here the difference will be calculated between the length of time remaining until the job is due and the length of its operation time. Okay, so here once again we have to consider the earliest due date and the processing time. Okay, how much processing time is required to complete all the operation on that particular job, and the second thing is how much time is remaining to deliver that product to the uh, to the uh, uh, to the customer. So the difference between that two things will be considered as a slack. Okay, will be considered as a slack. And here if the jobs are having the least slack, okay, such a jobs will be provided the highest priority. Okay, will be provided the highest priority. Then next priority sequencing criteria is longest processing time. Okay, LPT. So here if you want to provide the highest priority to longest processing time, okay, so that is nothing but if the thinking level of a management is like that, if this highest processing time jobs are completed, then small job will be completed within short time period. Okay, so in that case also if you can provide um, the highest priority to the longest processing time, LPD. And the last one is also important, that is nothing but preferred customer order. Okay, PCO. 1 minute. Okay, so the last one is nothing but preferred customer order. Okay, we know that some of the customers are favorable for the industries and giving the maximum business for the industries. So such a customer will be considered as a highest priority customer because such a customers are providing the maximum business or 50%, 75%, 80% business to the company. So some cases in this, if the situation like this, in that case, the preference will be provided to such a customer's orders, and the management tries to deliver such orders, customer orders as early as possible, so that the customer will have a faith and the customer will showcase some faith on the industry and will provide the another jobs or another business also to that particular company. So in this case we have to think about the customer mindset, and accordingly we have to provide the preference to the customer. So such a jobs whose the jobs of such a customers will be preferred first for the sequencing, and priority will be provided to such jobs, and that tasks are performed on the jobs as early as possible, and the components are delivered to the customer as early as possible. So this is these are the sequencing rule. So any of the rule can be selected according to the situation, and the priorities will be provided to the jobs. Okay, priorities will be provided to the job. Okay, getting? Is there any question, any doubt whether you understood what is meant by priority sequencing? Okay, so the next thing is nothing but, if the number of jobs are competing for a particular workstation, that is nothing but, if consider that there are 5 jobs or 4 variety of jobs or 10 variety of jobs, and that all the 10 variety of jobs having the common operation. Okay, let us consider, or that 10 variety of jobs required the common facility. Okay, that 10 variety of jobs are required the common facility. So in that case, the problem of sequencing arises. Okay, problem of sequencing arises. Okay, so sequencing problem arises whenever there is a need for determining an optimum order of performing a number of jobs by number of facilities according to some pre-assigned order, so as to optimize the output in terms of a cost and time of profit. Okay, so production of a finished goods from raw material consists of several operations to be performed in a given sequence. Frequently similar operations required for several products and performed at the same workstation. Okay, workstation, particularly in a intermittent or a batch production. Okay, under such a situation, it is required to select a preferred order for production passing through a workstation. The problem becomes complicated when the several workstations serves. Okay, so whenever we want to reduce the production time and we want to sequencing the operations, in that case we have to go for the sequencing of the jobs. Okay, so that is the main theme behind this particular slide. Okay, whether there is any problem, any question about the sequencing? Okay, so there are some assumptions required to go for the problems. That is, first one is no machine can process more than one job at a time. Okay, so particular machine can process only one job whatever assigned to that particular machine. So one machine cannot process the two jobs. So that is the basic assumption. Second assumption is processing time are independent of a processing of a jobs. Okay, so let us consider that there are number of jobs, 10 number of jobs. Okay, so the time required for the 10 number is 1 hour. Okay, 10 number of jobs. Then there are 20 number of jobs, so the time required will be 2 hours. So that is nothing but processing times are independent of a processing of a jobs. The third assumption is each job once started on one machine, it should be continued till completion on it. Okay, so if you take the 100 number of jobs or batch of a jobs, then that 100 number of a batch of a job should be completed in a one stroke only. Okay, so in between, after completion of a 20 job or after completion of a 30 jobs, so you should not go for the or you should not complete the partial jobs. Okay, you have to complete that particular complete batch, and then only you can go for the another batch. Okay, so that is the third assumption. Then time involves in a moving job from one machine to another is negligibly small. Okay, here we are not considering the transportation time from one machine to another machine, and that will be considered as a negligible or a small. So we are going to neglect that time from the processing time. Okay, so what kind of a problems will be there? So let us consider that there are n jobs and two machines. Okay, so let us consider 4 jobs are there, and the 4 jobs need to perform perform the operations on 2 machines. Okay, 2 different machines, and in a sequential manner. That is nothing but firstly you have to perform the operations of first machines, and then you have to perform the operations of a second machines. So if such a condition, so that problem statement comes under the problem type of n jobs and 2 machines. Okay, if there are 3 machines, okay, and there are 10 number of jobs or 5 number of jobs or 4 number of jobs, and each job should passes through 3 machines in a sequential manner, that the operations of a first machine should be performed on the first job, then it should be transferred to the second machine, then it should be transferred to the third machine. So that job category or that problem statement category comes under the n jobs and 3 machines. Now in this production operation management, we are going to deal with these 2 types of problem statements, that is n jobs and 2 machines and n jobs and 3 machines. Okay, here the n jobs and m machines or n jobs and m machines, like C and D problem statements, these types of problem statements are comes under the assignment problems. Okay, comes under the assignment problems, 2 jobs and m machines and n jobs and m machines. So these problems can be solved by considering the assignment problem. So I hope you learn these assignment problems in case of a operation research. Okay, in case of a operation research. So here once again we are going to deal with the first 2 varieties, that is n jobs and 2 machines, and second is nothing but n jobs and 3 machines. Okay, is there any question, any doubt up till now? Okay, so we'll complete the write-up part and then we will go for the next part. Okay, so that is nothing but problems. So write down priority sequencing. Priority sequencing. If you have any doubt, any question, you can ask. Okay, kindly let me know whether you understood priority sequencing, or is there any because there is so much disturbance in between, so linkage problem will also there. So that I want to ask you that if you understood, then let me know in the comment box. If not, I will repeat. You can type your question also. I will repeat that thing. Okay, so kindly let me know. Is there any problem, any question, whether you understood the things, because it is important part, and there are so many applications related to the priority sequencing. It will help you in IT sector also. It will help you in a mechanical. It is the core part, there is no problem, but it will help you in IT sector also. So the production operation management, there is no restriction. You can implement anywhere in any business. Okay, so uh, try to understand the concept. If there is any problem, any question, you can ask, or let me know that whether you understood or not. You can comment in the chat box. Okay, okay. So Yasar is replying every time. Others, I think they don't have the writing skills or typing skills. Okay, others also can comment whether you understood or not. If I judge all the students on the basis of Yasar Khatik's comment, then then every time I will ask to Yasar only whether Yasar you understood or not. Okay, so that will be the thing. So you comment your opinion. Is there any question, any doubt? Then you can comment that also. If anything not understood, then you can comment that also. I will repeat the things. No comment. Okay, let it be. I will. I hope everything is understood to everyone. Okay, so write down priority sequencing. Priority sequencing. Give the heading as priority sequencing. In that, you can write the first point: when jobs compete. When jobs compete. When jobs compete. In bracket participate. Participate. In bracket participate for work centers. For work centers. Work centers capacity. Work centers capacity. Comma. Which job should be done next? Which job should be done next? Question mark, full stop. Which job should be done next? Question mark, full stop. Priority sequence rules are applied. Priority sequence rules are applied to all jobs. To all jobs waiting in the sequence. Waiting in the sequence. Full stop. Then sequence. Then when the work centers becomes open, then when the work center becomes open for the job, for the job, for the job, comma, the one with the highest priority, the one with the highest priority, the one with the highest priority is assigned, is assigned, is assigned. One with the highest priority is assigned. In next point, in double inverted comma, priority sequencing. Priority sequencing is a systematic procedure. Priority sequencing is a systematic procedure. Priority sequencing is a systematic procedure for assigning priorities, for assigning priorities, for assigning priorities to waiting jobs, for assigning priorities to waiting jobs, thereby determining the sequence in which thereby determining the sequence in which the jobs will be performed. thereby determining the sequence in which the jobs will be performed. Okay. Next point, write down. Next heading, choosing criteria for sequencing. Choosing criteria for sequencing. Choosing criteria for sequencing. First one is setup cost. First one is setup cost. Setup cost. Second one is in-process inventory. In-process inventory. Third one is idle times. Third one is idle times. Idle times. Fourth one is average time to complete jobs. Fourth one is average time to complete jobs. Fifth one is average number of jobs waiting in the queue. Fifth one is average number of jobs waiting in the queue. And the last one is average time the jobs are late. Average time the jobs are late. Okay, average time the jobs are late. Okay, over. Next heading, give priority sequencing rules. Priority sequencing rules. Priority sequencing rules. First rule is first come, first served. FCFS. First come, first served. FCFS. In bracket, FCFS. In that you can write gives top priority to the waiting job, gives top priority to the waiting jobs that arrived earliest in the production system or to that particular work center. Gives top priority to the waiting jobs that arrives earliest in the production system. Second rule is earliest due date. Earliest due date. Short form is E capital D capital D, capital E capital D capital D. Okay, E double D. Earliest due date. In that you can write gives top priority to the waiting job, gives top priority to the waiting job whose due date is earliest. Whose due date is earliest. Gives top priority to the waiting job whose due date is earliest. Third rule is shortest processing time. Shortest processing time. Third one is shortest processing time. In bracket, capital S, capital P, capital T. SPT. Bracket complete. SPT. Bracket complete. In that you can write gives top priority to the waiting job, gives top priority to the waiting job whose operation time at work center is shortest. Gives top priority to the waiting job whose operation time at work center is shortest. Then fourth rule is least slack. LS. Least slack. Least slack. In that you can write slack is calculated as the difference of length of time. Slack is calculated as the difference of length of time Remaining slack is calculated as the difference of length of time remaining until until the job is due. Until the job is due. Slack is calculated as the difference of length of time remaining until the job is due and the length of its operation time, and the length. Okay, the next one is fifth one, longest processing time in bracket LPT, longest processing time in bracket LPT. And the sixth one is preferred customer order, PCO, preferred customer order in bracket PCO, preferred customer order. Okay, then what will be the statement for the sequencing problems where we can use this methodology or this scientific technique of a sequencing? So sequencing problems, write down the heading as small heading as sequencing problem. In that you can write the first point, the sequencing problem arises, the sequencing problem arises, the sequencing problem arises whenever sequencing problem arises whenever there is a need for determining, the sequencing problem arises whenever there is a need for determining, whenever there is a need for determining an optimum order, an optimum order, determining an optimum order of performing a number of jobs, of performing a number of jobs, of performing a number of jobs by number of facilities, by number of facilities according to some pre-assigned order, according to some pre-assigned order, so as to so as to so as to optimize the output, so as to optimize the output, so as to optimize the output, so as to optimize the output in terms of cost, in terms of cost, in terms of cost, comma, time or profit, in terms of cost, comma, time or profit, full stop, in terms of cost, comma, time or profit. Next point, production of finished goods. Next point, production of finished goods from raw materials, production of finished goods from raw materials consist of several operations, consists of several operations to be performed. Several operations to be performed in a given sequence. In a given sequence. In a given sequence, full stop, frequently, similar operations, frequently, comma, similar operations required for several products, similar operations required for several products are performed at the same workstations are performed at the same workstation particularly in intermittent or batch production in intermittent or batch production. Next point, under such a situation, comma, it is required to select a preferred order. It is required to select a preferred order for production passing through a workstations. It is required to select a preferred order for production passing through a workstation. Full stop. The problem becomes complicated. The problem becomes complicated when the several workstations serves many products. When the several workstations serves many products. Full stop. In such a problem, comma, the criteria is minimum total processing time. In such a problem, the criteria is minimum total processing time. Okay. So जब भी ये प्रॉब्लम आ जाएगा तब हमें कौन सा क्राइटेरिया यूज करना है? मिनिमम टोटल प्रोसेसिंग टाइम का हमें क्राइटेरिया यूज करना है. ओके, सो दिस इज इंपॉर्टेंट कंसेप्ट, minimum total processing time for a particular job. Okay, getting? Then assumptions to solve the problems. Okay, assumptions to solve the problems. Write down the first assumption. No machine, first one is no machine can process more than one job. No machine can process more than one job at a time. Okay, first point is no machine can process more than one job at a time. No machine can process more than one job at a time. Second one, processing times are independent of processing of jobs. processing times are independent of processing of jobs. Then third one is each job once started, each job once started on one machine, each job once started on one machine, it's continued till completion on it. It's continued till completion on it. And the fourth one is time involved in moving a job from one machine, time involved in moving a job from one machine to another is negligibly small, is negligibly small. Then next point you can write assumptions, or next point you can write satisfactory solutions are available. Satisfactory solutions are available for the following problems. Satisfactory solutions are available for the following problems. So these four different problem statements. First one is n jobs and two machines. N jobs and two machines. N jobs and two machines. Second one is n jobs and three machines. N jobs and three machines. Third one is two jobs and m machines. Two jobs and m machines. And the last one is n jobs and m machines. N jobs and m machines. N jobs and m machines. Okay. So we are going to discuss the first problem statement and the second problem statement. That is nothing but n jobs and two machines problems, which can be solved by using Johnson's algorithm. And the second problem statement is nothing but n jobs and three machines. Okay. So this two problem statement will be considered as a sequencing problem statements, and other two problem statement, that is two jobs and m machines and n jobs and m machines, these two problem statement will be solved by using the assignment problems. Okay. So in this point we are going to discuss only two types of a problem statement. So in the next lecture we are going to understand these two problem statements, and we are going to solve the variety of problems on these two problem statements. Okay. So is there any question, any doubt? Okay. Is there any question, any doubt? If you have any question, any problem, you can ask, or else you can comment your roll numbers in the chat box and you can leave this meeting. Okay. So next lecture will be conducted at 2 p.m. and in that lecture we are going to take the problems on sequencing, priority sequencing. Okay. So everyone attend that lecture.